Good day everybody, it's Rob here from tyFlow. We're going to make a couple of parts to work with PhysX and tyFlow, right? So I got this gear that I made from a script available on ScriptSpot called Gears. It still works in 2024. Once you've installed it, it'll come over here and create. You go down here, in your standard ones, and scroll all the way down, and over here you see examples, and then there's a gear thing appear here, right? I'll give you the specs for these gears in a minute, but what we need to think about when we make a gear like this is we need to break this down to work within tyFlow. Now you can use, animation controllers and wiring to do the same effect, but let's forget the reason why you want to do this, and let's just do it. And how do you make a gear? And then you can decide what you might want to make with those gears. And for example, a little cart that's being driven by a shaft, and when it goes over a bump or a hill, the gears turn. Whatever, it doesn't matter. The point is, how do we make stuff to work within PhysX? We've already partially covered it, but I kind of had a request about this regarding my bicycle chain. So first of all, we got this 20-point gear, and importantly, it's been centered on the origin in every way, and that'll become important as we draw all our components for our teeth. So what we need to do is, when we look at tyFlow, right, and it's going to, when you shrink wrap this, it's going to not come in and fill this out like this. Our shrink wrap isn't going to go like this, right? It's going to go right across and encase the whole thing. So the first thing we do is need to do the thing where we break everything down into components, right? So let's make one set of sprocket teeth. Right now we can see that it's off center, and I'm just going to rotate it to make it easy to work with right this second, right? So let's go ahead and do that, and I'll try and do it as quickly as I can. So rotate here. I think that's close enough. So we'll do this tooth here, right? So what I'm going to do is come over here and turn my snaps on, and I've got it set to vertex and 2.5D, so it creates them all on the same plane. We'll zoom right in here on this tooth, right? And we'll come over here and create a line. So now we need to break it down into shrink wrappable objects, right? So let's start with this tip here, for example. Boom, 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 boom. There's our first one, right? Remembering where we were, this will be all right for shrink wrap. There's our second one. We'll do our third one here. And then we'll go to the corner . Alright, so the teeth aren't actually going to go all the way down here. So if we kind of go now, we need something that can be rotated and lined up perfectly, right? So if we use what's already here from the gear, alright, and go to these center lines, now we should have all the elements we need for actually making the gear. So we need to be able to see those elements and extrude them, right? So if I turn this off, here's what we created, right? So if I just grab those and make them all the same color for now, something bright so you can see them. There you can see the elements of what we need to be able to clone. So let's extrude all those, and I'll turn snap off. Let's extrude all those. I'm just going to do 5 because that's my thing, 5 centimeters here for size. 5, extrude. extrude, 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 and extrude. So now when we look in the overall here, we can see our beginning of our tooth section that's compatible with working in tyFlow PhysX, right? So now think about texturing. Always think about texturing. What are you going to do? For now I just want all of these to be one, but let's convert each one of these into editable poly. Convert to editable poly. Then we attach them, right? We come down here and we attach. Boom, 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 and boom. And now we have our single tooth ready for cloning. Right, but we're going to go in here and make sure our texturing is correct. So we go into polygons, select all our polygons, and for now I'm just going to make them all material 1. Make sure that that's what they're set to. Now we're ready to cloning. And because we centered our original sprocket on the origin, we kind of want to do the same to our pivot here, right? So we're going to go into effect pivot only, and we're going to move it to the origin, right? So come down the bottom here and 0 it. And it doesn't matter if we 0 it as the said, but it'll move it off center, but that's okay for now, right? As long as the X and Y is good. Now, if we clone it correctly, now if we rotate and clone, I need my angle snaps on. What's it set to? 9. Let's just do 5. It should work, I hope. There's 20 sprockets, right? There's 20 teeth on this one. So 360 divided by 20 should be 18 degrees, right? Is that right? I think so. Which is not compatible with what we got. So let's just do 18. And let's rotate. There you go. Now 18 is the right, and we want, there's 20 teeth, so we want 19 copies. It's easy if you make a copy for attaching, right? So for now, make it 19 copies. Dunk. And there's the beginnings of our full-on sprocket. We just pick our original tooth or whatever here, and we go back to modify, and now we attach all our teeth, right? Alright, so that's the beginnings of our sprocket. I'll be right back. We'll create the centerpiece, because when you think about how this should work within tyFlow, right? If we center in all the windows so you can see. If you think about how this should work within tyFlow, ideally this is going to be a dynamic object, and the easiest way to do that is we actually put the shaft on the dynamic object, and we put whatever the shaft's going to go into, the holes or whatever, on a mesh object, because it just makes it easier. We don't have to do anything with the other one, right? So I'll be right back. Alright, so I'm back. All I've done is create a few cylinders, right? So we got the gear that we made here that's been centered and all attached, right? Then we need a center bit to fill in the hole that we had. So I just got this larger cylinder here, and on that one I did 32 sides, because what we're thinking about later on is a smooth surface on the shaft for it to rotate on, right? And then we've got a smaller cylinder that's what I'm going to use as a bearing, and you can see over here rough dimensions. Then we got the shaft, which is 4 centimeters. But then what we're going to use is a boolean, a shaft for the boolean that's going to come out of the bearing, which you see is 4.1. Now 4.1 might be a bit too big when you kind of see here how much gap there's going to be for rotation purposes. Alright, but let's finish the gear off. So the best way here is to have the gear complete with a shaft attached, right? So if we go to our gear and attach our centerpiece here, right, and then we also want to attach the shaft. So there we now have a gear with a shaft. If we turn off attach here and just rename this, and we temporarily hide that. Alright, now what we're left with is the cylinder that was slightly bigger, right, for rotation purposes, and the thing that we're going to use as a bearing. So when we look here, alright, we got what we're going to do a boolean on. So we're going to select our bearing and then boolean subtract and take that away, right? And that gives us a bearing. Convert that to editable poly, and now we have a bearing. We turn our sprocket back on. Now we have a gear with one bearing, and if we come over here and pick our bearing and we bring that over here and make a second bearing, now we have a sprocket gear that's going to work with tyFlow and rotate inside these bearings based on whatever happens to this sprocket, right? Alright, so I just tweaked the model a little bit to make it easier to see, right? I want you to see rotation, so I just changed the texturing on the sprocket that we made, right? And I just kind of set up this little multi-sub object here with textures, dropped it on tyFlow, and we go in and we create a tyFlow, and I've pre-made some of it so you're not watching me, but it's easy, you know. Birth object, I picked the sprocket we made, alright. I turn it into a PhysX shape, and it's compound from elements. That's why we broke down the model the way we did in little elements. So, and if we display the whole, sorry, we're not in tyFlow right now. Let me switch. And if we display the whole, you can see that we've got ourselves a nice fitting hole, right? That fits, and it's not, you know, there's a little shortcut across the edges there, but I told you the teeth don't going to go all the way down, so it's not a problem. So our hole should be good. Alright, and as far as the bearings, you know, I've birthed the two bearings that we made, and they're PhysX shape, and I've made them a mesh. Now a mesh object is a kinematic object not controlled by dynamics or physics. It's just going to suspend in air, but it's going to hold the gear in place and make the gear a freewheeling thing. I've decreased the static friction. Originally this is 0.5 and 0.5. I've just decreased the friction on this so it's easier for this sprocket to turn inside the bearings, and I've turned on the mass override on the bearings. That's it. That's the only changes that I've done. I've pre-made 4 balls here so that we can test whether or not this gear will behave as if it's a dynamic object, right? So if we first of all, if we animate right now, nothing should happen except we see ever so slight a movement in the gear. I don't know if you can see that, but you can just see a slight movement. Probably means that it's settling into the bearings. So technically now, if we turn in our spears that have been lined up to hit the sprocket, right? And we let them come down, you can see that the sprocket is turning based on being hit by those balls. And if we play the animation, we should see some jerkiness because it should coincide with being hit by the balls. And let's see if we can get a better angle here. But there you go, that's a dynamic gear made to work within tyFlow PhysX. I'll come back and just show you another example of a multi-gear setup and just explain a couple of things to look out for. Just for clarity, on the spheres, I made them heavier, right? So when you see the mass, they're at 40. Compared to the default value of 1, I've turned off relative to size, right? I've made them 40 so that this tiny ball has enough weight or mass to impact our gear. Now let's move on to the other example, which has some important points in it. Alright, so I'm back. Here's the gear we built earlier, and here's two with 40 teeth using exactly the same method for this smaller one. Now, one thing you do got to watch out for is when you build the gears in different size, the two settings, they've got to be the same in the tooth sizing, the parameters in the gear script that I used, right? But you can read that, it's on the web page where you get the script from. But anyway, what I've done right now is I'm going to use this. Now before this was dynamic, and it still is right now, but we don't want it to be because it's going to cause problems, right? These two are going to be purely driven by this sprocket, so these two have been set up to be dynamic. What I did on this little one, over 100 frames, it's doing a 360-degree rotation, alright, over 100 frames. So that's been keyframed. If I select the sprocket, you can see the two keyframes down the bottom, and that's all I've done on rotation. So now when we go into tyFlow here, I'm going to switch the layers. Alright, so now we're looking at tyFlow. These are tyFlow created objects, and when we look at the flow, alright, we just got one for all the 6 bearings, alright, 2 for the larger sprockets. Let me rename this large sprockets dynamic, and up here I've called this small sprocket keyframed, right, on rotation. And to make this work, you go in here and say inherit rotation. Now right now it's compiled by elements, which is how we left it. I'll turn off the whole because we don't need it. Right, and I'm going to show you a small problem. Now you don't want this really. Compound by elements makes this a dynamic object, but we're looking at rotation and we've put rotation on it. That's going to cause problems in your animation. So if we look and go through, I'm going to have to catch the spot. It's starting to drive everything okay, everything's okay, it's trying. Whoop, you saw the glitch, right? See the glitch? And now all of a sudden, if we zoom in and you see the teeth are intersecting each other, right? That's because this small gear right now is set up to be a dynamic object, but it's being driven by rotation we've keyframed. If you're going to drive anything like this by keyframe, right, then you might as well make it a mesh object, because it's no longer a PhysX object really, right? So if I go back in here and now just turn this into a mesh, it means that technically we didn't need the bearings because it's going to be hovering in space. Alright, it's still going to look at the inherent rotation, but now it's going to behave much more the way that we want it to, right? Let me get rid of this. So the only thing now we did was make this mesh rather than compound from elements. And now we can see how smoothly everything is being driven, right? There's no glitches. If we play the animation, it plays really smooth, right? And we can change the rotation and everything. There's a little bit of wiggling on here, but that's because we've got too much gap to the bearings. We could pick these bearings and scale them down a little bit to be tighter on the shaft. That way we won't get the jiggling. And I'll just change the zoom here right now a little bit. So we have 3 gears that are tyFlow compatible. One that's driving the animation because we keyframed it rotation wise. These two are totally interacting based on what this thing's doing. So these are 100% dynamic. There's just an example of tyFlow PhysX driving gears, right? Like I said, you could do it with wiring and animation constraints and all that stuff, and controllers, but there might be a reason that you want to do it this way. The point is not why we did it. The point is we can do it if we want to, and we can have stuff in Max do whatever based on PhysX and tyFlow. I'll show a little quick example of a stupid little cut thing, okay, and we'll leave it at that. But that's gears driven by PhysX. Alright, so here's this silly little animation I was talking about. But what's really cool about this is everything in here is dynamic. The gears are dynamic. The frames holding the gears are dynamic. Alright, all of it is being totally controlled by PhysX. There is no keyframing whatsoever in this animation. Alright, the frames hit the ramp. It's just a test. They fall over. You see jiggling when they fall over. You see how the gears are interacting with the ramp, the stepped ramp. You see the movement of the gears on the ground, the connection between the gears. They're rotating. This gear here is totally being driven by these other two, right? And then the net, you see when the net falls over, how it falls very tight. You can even see in places it's right up against the gaps in the gears. So all our holes are made to perfection in a way, right? Now I'll just pause this video here, somewhere here. And this is the same process we use to make the gear, except in this instance all three gears are the same. And I didn't go quite as far in. When we made the tooth before, we came kind of here. I wanted to have this holy look to help indicate rotation and movement. So I just made a larger cylinder here, and then I did some Boolean cylinders spaced at even spaces, and made gear to look like that. Now the only reason you might not want to do that is if somehow you're going to pass balls through there, but you're not going to, right? But anyway, this is how I did it. And you can see here as it comes down the ramp, it's totally being driven. All the gears are rotating correctly, right? It's just kind of cool, right? And on the frame here, these are oversized bearings as far as the depth and everything, because I knew I was going to put them to a frame, right? So what I did was made one bearing, and here's the important thing on this bearing, right? Go into my little sketchy drawing here. And on each bearing, after I made them, I had to split each into elements, right? So that I could do whole compound by element, because in this case, the frame is going to be dynamic, right? Because it's going to be moving with the wheels, the sprockets. So, you know, each bearing, I just did one, and then I cloned it to all 6 spots, right? So, because there's 3 per side, right? And then just to make the frame hold together, so it doesn't just fall off the cogs, once I did, you know, like you have looking from above, right? You have the frame, say a bearing and a bearing. This is looking from above, right? And then over here you have a frame with your 3 bearings, right? And in between you have your sprockets with their shafts, right? When I did all this bearing, once I'd made one and broken the small one into its elements, then I just cloned it to all the positions, cloned the frame, and then, you know, I attached. So I picked one, attach, 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 and then because I also attached this other side, you know, so this whole frame became one piece without the sprockets. That now makes that all hold together, and the sprocket's going to sit in between. I mean, technically, if I was doing it to make it look real, I would have put some sort of frame in between so, you know, they can't fall apart, but, you know, that's just an oversight on my part. And let's just take a look at that, right? If we go into the layer menu for a minute here and switch around and come back to the beginning here. Now here you can see this is the mesh we're looking at now, right? And if I go in and pick this frame, and you can see how from the top view here, you can see how they're all connected, and you can see how nice and tight I got them into the sprockets. But if we go and look at elements, each box is its element. But now look at the bearings. We'll just zoom in closer to this bearing, right? And you can see how tight I've made it around the shaft. You can see that I've actually broken each bearing into small elements like that, right? We've shown that in a previous tutorial. So, but that's just an example of how you would make a fully dynamic, PhysX driven gear kind of animation where nothing whatsoever in this scene is keyframed. Oops. I'll just take a look at it one more time before we go. I mean, I hope you found something useful in here. We'll make a couple more tutorials on PhysX kind of driven object creation and stuff like that, but we're going to leave it right here for now on this one. And take it easy, everybody.